So hey guys, we are going to discuss question 813, which is largest sum of average. This question is quite tricky, but let me explain you what this question is trying to say. So basically we have given an array nums and we have given integer k. So what we can do, we can divide array nums in at most k sub-arrays or k parts. For example, like we have given k equals to 3, we can divide this array in 3 parts. For example, this is a first part, this is a second part, this is a third part. There is one more thing, like you have given k, so it's not compulsory just to divide 3 times. You can divide it in 2 times also, 1 time also. For example, if you divide your array in 2 parts, this will be your first part, this will be your second part. So at most you can divide it into k parts. Okay, and what it is asking is we have to find the maximum or the largest of the average of those sub-arrays. If you couldn't understand, let me explain. It's like we have array this nums. We'll divide it in parts at most k times, such that the average of those parts, and we'll sum all the averages, which will result into a maximum value. For example, if you divide your array in this way, the average of this will be 9 by 1, because sum is 9 divided by number of element 1, which will be 9. And if you find average of this, it will give you 3 plus 2 plus 1, which will be 6 by 3, which will be 2. If you find average of this, same, it will be 9, so it will be 20. For example, if you divide your array in a different way, for example, if you divide your array in this manner, so average of this part will be 9, average of this whole part will be 9 plus 9 plus 3 plus 2 plus 1 divided by number of element should be 4. So 9 plus 1 10, 10 plus 5 15 by 4, 15 by 4 is equals to 5, somewhere around 4. So this whole term will turn to 4, around 4. So 9 plus 4, which will be 13, and you'll try all possibilities. So the maximum sum that you can get is 20, and you have to return this. So hope you understand the question and what the question is asking. So how you will approach? Like you have to divide an array into sub-arrays at most k times, and at every index you have a choice if you want to divide or not. Okay, you can try from any index. If you try to divide an array from this index, you must have sum of element before this. For example, 9 plus 1 10, and sum and average, you can say sum and number of element, which will give you average, because average is equals to sum of element divided by number of element. Okay, so this should be your average, so you should have that in your mind, and you should have k, which will be the number of cuts that you are making. Okay, and like if you divide from here, then you have chance your k will be 2. Then you can cut from anywhere. What will be your base case? Base case is simply like if you reach at the last index, or your index, the pointer that you are having, if you are marking cut out of this array, you will simply return 0. Okay, as simple as that. Let me tell you one more thing. Like if you are dividing an array from here, so you have to find average of this and this. If you are dividing array from here and this position, you have to find average of this and this part. Okay, if you just divide it into this and this, you have to again find average of this part and this part. You can see you are doing the repetitive work, and to avoid this repetitive work, what you can do? The answer is using a memoized solution. Okay, if you could understand, let me just show you. For example, you have this array, you are making a cut here. Okay, then you must be having average of this and average of this. Again, if you are making cut here at the same position and another cut at this position, you must calculate the average of this. Again, you are calculating the average of this, then you will calculate average of this and this. So as you can see, you are doing extra work. To avoid that, you will simply use a DP. So let me take you to the coding part.
So, okay, this was the question, and we'll code it up. First, you need to create a vector dp array, which will be of, instead of type int, we'll make it floating point or double. You can say, okay. Size will be nums dot size, comma vector double. Size will be k, initialize with 0. Okay. Then we'll call our recursive function f. Static index will be 0. We'll pass all the other parameters. Wait a second. I have named the TP array. So double f. This will be a function anti index comma anti vector anti create nums anti k and vector will pass a TP. DP array as a reference. We'll discuss the base case later. Then we'll simply form a recursion. For that, we'll start anti I from index to I less than n nums dot size. Okay, and what we'll do, we have to basically just find the sum of the elements till that, and we have to find the average. So how you can find the sum? Sum will be, firstly sum will be 0. Sum plus equals to sum equals to 0. Average, you can say it will be 0, or should be double instead. Sum is 0, average equals to 0.0, you can initialize and a length variable and equals to 0. So first we'll add sum plus equals to nums of I will increase the count as we are adding that integer or that number in our current array or sub array, you can say. So length will increase by 1. You add it in the sum. At last you'll find the average. Average is simply sum divided by length, and what we'll do, we'll store it in an answer. Answer will have a maximum value. Maximum, as you have to return the largest sum. So max of answer, that last sum of the division partition that we had, and compare with the current, and current will be sum plus we'll call the function recursively index plus 1 comma nums comma k will reduce to 1 as we partitioned our array. We'll pass simply dp array, return dp of index comma k equals to answer we didn't initialize answer, or you can say answer double equals to double answer equals to int min, you can say. And what will be our base case? If our index is greater or equals to n, will return 0. Okay. Or if our partition, you can say k double equals to 0 reaches 0 before reaching the index 0, then we'll return int min, because that will not be a possible solution. And for dp to work, we will include memoization. dp of index comma k is not equals to 0, and return dp of index comma k. Okay, so let me just run this code quickly. Let me check if there is any error or not. Index greater equals to n, nums dot size, you can say nums dot size. Oh, sorry, answer. Nums dot size. Let me check. There is one more error. Mistake we were making was simply as we were passing index instead of I, as I will be the point that we are dividing or we are partitioning a sub array. For example, if we are partitioning our array at index 0, so I will be 0, so we'll pass the next index or the remaining sub array, which will start from 1. So thank you.
Like and subscribe to my YouTube channel. Bye bye.
I don't believe in destiny, I just do what's best for me. Don't listen to my